Here we have traversal algorithm. We have three most commonly used algorithms in traversal algorithm, which are pre-order, in-order, and post-order traversals. For pre-order, we order the vertices of a tree by starting from root, then left subtree, and then right subtree. For example, if we have a tree like this one, we start from the root, then left subtree, then right subtree. It's like that. First, this is the first one, this is the second one, and then it's the third one, it's the fourth, and it's the fifth one. We order these vertices like this. First the root, then to the left subtrees, and then the right subtrees. And here we have in order. In order, we say we start from the left subtree. We start from the left subtree. That means you start from this one, then root. We start, and then this one, and then left subtree, this and that one. Oh, sorry, and this. Okay. We start from the left subtree, and then root, then right subtree. We will take an example about each of these later on. And then we have post order. Here we have left subtree first, then right subtree, and then root. We order in this way. First, we write down the left subtree, then right subtree, and then the root. Okay. We're gonna order in that way. This is the procedure or the process of working for pre-order. For pre-order traversal, we say we first write down the root, then left subtree, and then right subtree. This is the procedure or the algorithm for doing this process. Here we have an example. In this example, we have given a tree. We just work on the trees for this for these three type of traversals. We must have trees. For this tree, we are gonna find the pre-order for this tree. How? We start from the vertex. That means the first element, the first vertex that we should write down is the vertex. Then we write down the left subtree. We write down the subtrees from left to right. At first we have this one, then we have C, and we also have this one. Okay, we have these three subtrees for vertex A, for root A. A is the root. We first write down the root, which is the most left one, which is the first vertex that we should write down. And then we write down the rightmost subtree. Then we write down C, which is the second subtree from the left. And then we write down this subtree, which is the most right one. Right subtree. Now, what we do, and then for this tree, we do the same. And for this tree, we do the same also. But here, the first element is A. And then we have B, look, B, then we have E, sorry. We have B, E, then we have I and J. We first write down B. Okay, as I said, it's from the root to down. Okay, then we have E. And then for these two trees, we write down I first, then J. As I said, we are going to write down from right subtree, then left subtree. It's I, J. So this one, this subtree becomes B, E, I, J. It becomes B, E, I, J. So here we have A, then B, E, I, J, and here we have C also. We have C. After this subtree, we have C. Then we have this subtree. It's also a tree. For this tree, we first write down the roots. For this tree, each subtree is a tree and has the root. Here, the root here is D. We write down the root. Then left subtree and right subtree. Here, we come to here. And when we come to here, we have F, then K. And then we have this subtree, which is G. And then you have this one. It's H, L, and M. First, we write down H, then L, and M. This is the pre-order for that tree. It's pre-order traversal for that tree. As you see here, we start from the vertex or the root. We start from the root for the graph. The root for the tree is A. We first write down as the most right one. That's it. Then we take the left subtree, then the middle subtree, and the right subtrees. Here we have B, E, I, J. This one is the left subtree. And the middle subtree is only C. It's only a vertex. And the right subtree is D, and these are vertices. This is the right subtree. That means here, the first element is A. Then write down all the elements of the second of the left subtree, which is B, E, I, and J. Write down these vertices. Then after this, we have C. We should write down C, and then the right subtree. For the right subtree, we follow the same as we did before. We first write down the vertices, the root, and then the left subtree and the right subtree. Okay, here for this subtree, it becomes a tree also. First, we write down the root, then the left subtree, then middle subtree, and then the right subtree. When we take the right subtree, here we have H. Then we take the left element and the left leaf and the right. That's the pre-order of the pre-order traversal of a tree. Okay, this is the process. First, the graph becomes like that. The tree becomes these subtrees and vertices. Here, this is the root. Then we have the left subtree, which is a B, E, I, and J. Then the middle subtree is only C, and the right subtree is this one. Now, we work on each of these two subtrees also. These two subtrees are trees also. Yeah, we write down B first. So the first element is A. Then we write down B. What's left here is this subtree. We have this subtree. Then we have C. Then we write down D. D is the root here. We write down it. Then we have left subtree, which is F and K. Then we have this vertex, which is the middle subtree, G. And we have the right subtree, which is H, L, and M. That's it. Now we work on these two. We work on these two trees. For this tree, we first write down the left one and the right one. But before these two, we should write down the root. The root is E. So here, between B and C, we have this tree, this rooted tree. We write down the root, which is E, then the left one, and then the right one, which is E, I, and J. Between A and C, B and C, between these two, we have these three vertices, E, I, and J. Okay, then we have D. And between D and G, we have this tree. We write down the root, which is F, then K, F and K, which is between D and G. And then after G, we have this root tree. We first write down the root, which is H, then we write down the left one and the right one, which is L and M. This is the pre-ordered traversal for the given tree. Okay, this is the process. You should first write down the root, then subtrees from left to right, and then the subtrees become tree again, and then write down for the root for each subtree, then the left and right subtrees for each subtree, and then till you get this form. So this is the pre-ordered traversal of the root tree. Now we have in order traversal. This is the procedure of working on the tree to write down the in order traversal. Okay, I'm going to explain it on the example. It's easier to get the idea. Here we have given this tree. If we return to the definition of in order, here we say we first write down left subtree, then right root, and then the right subtree. We first write down the left subtree, then root, then the right subtree. Here we have given this tree, and we are asked to write down the in order traversal. What we do? We should first write down the left subtree. The left subtree is B-E-I-J. B-E-I-J is the left subtree. We are going to write down this one. Then write down the root. This is the root, which is A. Then the right subtrees. Here you have C. Then this subtree. Now, in another step, we have this tree and that tree. Okay, for the left one, for B-E-I-N-J, for this one, we write down the left subtree, then the root. Here we have only this subtree from B. We have only this subtree from B. So we write down it. With E-I-N-J. Then we write down the root for this tree. For each subtree, we have the root also. Yeah, B is the root, and this is the it has only this subtree. We write down it. Then we have A and C. We write down in the same order. Then to this subtree or this tree. For this tree, we write down the left one, which is FK. Then the root, which is D. Here you have G also. And then the right subtree. This is the right subtree. So the right subtree is H, L, and M. We write down it like this. Now we have only one more step here. We have this tree, and this tree. For each of these trees, we first write down the left subtree, the root, then the right subtree. Okay. For this one, we write down I, E, and J in this order. And here we have B, A, C. We are going to write down them in the same order. Then here we have only one leaf from F. We write down the leaf, which is the subtree, K, then F. D and G, we write down them in the same order. And here we have H, L, and M. We write down the left subtree, then the root, and then the right subtree, which is L, H, and M. This is the in order traversal. Look, this is the same as the same tree as the previous example. In the previous example, you found pre-order traversal. This is the order of the vertices. Yeah, in pre-order, in order, and post-order traversals, we just order the vertices. We just order the vertices here. This is the pre-order traversal. It's in this order: A, B, E, I, J, and so on. But the in order traversal, it's I, E, J, B, A. Look, they are different. They are ordered in different ways. Okay, these are different ordering of the vertices of that tree. So the process is this: to write down first left subtree, then root and right subtree. We do it step by step till we get this form. Okay. We now have post-order traversal. For post-order traversal, this is the procedure. The procedure of working on the tree to find the post-order traversal is this one. This is the algorithm of finding the post-order traversal. I'm going to talk about the example. It's much easier to understand how to work on the root tree to find the post-order traversal. Here we have given the same as the above example. This is a tree. We have given this rooted tree. We are asked to find the post-order traversal. The post-order traversal. What we do here? Let's return to the definition of post-order. Look, we write down first left subtree. We write down left subtree, then right subtree, then the root. We write down left subtree, right subtree, then the root. Let's work on it. Here, this is the left subtree. This is the left subtree. Then we have this subtree also. We are going to write down all the subtrees from left to right. From left to right. For example, if we have something like this, if we have something like this, we first write down this subtree, then we write down this subtree, and then we write down this one. Okay, we are gonna write down all the subtrees from left to right. Then we write down the roots. This is the root. The most top one is the root in a tree. Here we write down the most left subtree, then the second subtree, which is only C. Here we have only C, and then the right subtree, which is this one. This is the right subtree. And finally, we write down the root. The root is A here. It's the most top one. It's the top one. This is the root. We write down it in this order. First, left subtree, then middle one, and then the right one. And finally, we write down the root, which is A here. This is the most left one, then the middle one, and the right one. These are the subtrees, and this is the root. Now we have this tree and this tree. For each of these two trees, we do the same. We do the same. What we do? We are going to write down. Yeah, this is the root. This is the root, and it has only this subtree. We write down the subtree first, then the root. write down the subtree first, then the root. Okay. And here we have C also. We write down in the same order. Now we have D. D is the root. In D, we have this, and this subtrees. We have these three subtrees. Yeah, this is a tree. This is a tree. In this tree, D is the root. So we must first write down all the subtrees, then the roots. So the subtrees are this one, F and K, then G, and then this one, H, L, and M, and then the root away توبة كوتا جات رودا كان جاري ليفتو ميظلو كوتا هالشان subtree هبي ينوسين لشاف بوراس إن جادوات رودا كان نوسين. That's it. Now in the next step, what we do here, we have this tree and this tree. يك تري كان هلا وشين يك شون صارت لايتشا أقلنا وراس نجا لا راس دواتل top. Okay, here we have left subtree which is I and right subtree is J, then E. We write down it's in this order. We must write down left subtree, right subtree, then the here for this tree the root is E. The root is E. We write down I first, then J, and then E. E is the root here. And B and C, we have B and C here. أوانيك هم أنا element have vertex sign كمان بهمان order يعني C. نبي B و C بين بيشانو. بهمان order B و C. Must write down in the same order. Okay, so this subtree or this tree becomes I, J, and E. As you see, first write down the left one and the right one, then the root I, J, E. And here after this one, this tree, we have B and C. We have B and C. Then for F, K, for this tree, we write down the subtree, then the root. It's K and F. Then we have G. G is alone. We write down the same. And for this tree, we have the left one, then the right one, and the root with L, M, and H. And here we have D and A. We write down them in the same order. So this is the post-order traversal. Look, we found in order, pre-order, and post-order traversal for the same root tree, and all are different. Look, this is I, J, E, B. A is the last one. A is the last one here. But in order, A is here. Okay. For pre-order, A is the first one. For pre-order, we first write down the root, which is the most top one, then left subtree and right subtree. It's for pre-order. For in order, we write down left subtree, the root, then the right subtree. But for post order, we write down left subtree, right subtree, then the root. It's how to find post order, in order, and pre-order traversal for a root tree. Here we have some exercises about what we talked about now. We now have spanning trees. We have spanning trees. We say a spanning tree is a simple graph that's a subgraph of G. Spanning tree is a simple graph that we take from a graph, the graph G. It's a subtree. It's a subgraph of a given graph. It contains every vertex of G. So here, this tree, we take a tree from a graph which contains all the vertex of the graph. as you see here, we have this graph. We must take a tree from it. That means we must have no closed cycles. In trees, we must have no closed cycles. Look, for this one, this is a graph. It's not a tree because here we have a closed cycle. We have closed cycles. This one, or this one, or this one, or this one. We have closed cycles. In trees, we must have no closed cycles. Okay? We have given this graph. So the spanning tree for this graph, we have many spanning tree. Okay, it's not unique. It's not unique. For example, we take any tree which contains all the vertices of graph G. Yeah, if you go on the graph like this, then this is our graph. Okay, may someone say, I'm going to take this, and this one. This is a tree. This is a tree, and it contains all the vertices. Here we have only these 4 vertices. This, and this. That means the spanning graph or the spanning tree is this. May someone take this one. May someone else take in this way. In this way. Look. The most important here is the graph or the tree includes all the vertices. Look, this vertex, this, and that one. This one also contains all the vertices of the graph. Here in this graph, we have only 4 vertices, which are, let's name them 1, 2, 3, and 4. Each of these 2 trees, look, these are trees because this doesn't contain any closed cycle. And also, the number of nodes is more than the number of edges by 1. The number of nodes is more than the number of edges by 1. As you see here, the number of nodes, I mean the number of vertices. Here we have 4 vertices, and we have 3 edges. For this one also, we have 4 vertices and 3 edges. May someone else take it like this. This, and this. As you see, it's a subgraph of the given graph. This is a vertex 2, this is 4, this is 3, that's 1. This is a subgraph of the given graph. And it's a tree. It's a tree. Okay. Here we have 4 vertices and 3 edges. May someone else take it like this. This is also the spanning tree of that given graph. May someone else take it like this. This is also a spanning tree of that given graph. Here, these are also found. May someone else take it like this. This is also a spanning tree for the given graph. Okay. Here, the most important thing here is to find a tree which contains all the vertices of the graph. And you should know that the spanning tree is not unique. We may have more than 1 spanning tree. These all are spanning trees for that given graph. Now, we have minimum spanning tree. We say a minimum spanning tree is a spanning tree on a weighted graph that has minimum total weight. Yeah, if the graph is weighted, the minimum spanning tree is that tree which contains all the vertices of the graph and it has the minimum total weight. It has the minimum total weight. For example, here we have given this weighted graph. As you see, the weight of each edge is given. The weight of each edge is given. The weight of this edge, which from A to B, is 5. The weight of this one is 2. The weight of this edge is 6. And the weight of this edge is 7. This one is 3, and this one is 4. Okay, this is called weighted graph. Now, to find the weight of each spanning tree, let's take some spanning tree from it. This is a spanning tree from this graph. This is a spanning tree for that graph. And the weight of this spanning tree is find the total weight of the spanning tree. 2 plus 5 plus 3 was 10. That means here the weight of this spanning tree is 10. The weight of this spanning tree is 10. It's okay. The weight for the spanning tree is 10. And for this one, this is also a spanning tree for that graph. Now, we have the weight of this edge is 2, the weight of this edge is 6, and the weight of this edge is 4. We are going to find the sum of all weighted. Okay? We're going to find the sum of weight for all the edges. It's 2 plus 6 is 8 plus 4 is 12. For this spanning tree, its weight is 12. And for this one, it's 2 plus 7 plus 3, which is 12. For this one is 12 also. Okay. Here, these weights are the same as those which are given in the graph. Here, from A to B is 5. As you see, it's 5. From, let's say, from A to D, from A to D is 7. As you see, 7. Okay. These weights that you have written down in the spanning trees are the same as given, are the same as those which are given in the exam, in the graph. These all are spanning trees. Okay. And the weight of this graph is 10, of this spanning tree is 10. And the weight of this spanning tree is 12. The weight of this spanning tree is 12. And the weight of this spanning tree is 12. Let's take another spanning tree from it. Let's say we take this one. Okay. This is C, this is D, this is B, and this is A. The weight of this edge is 2, this is 4, and this is 3. And the total weight of this spanning tree is 2 plus 4 is 6 plus 3 is 9. So let's say it's T4. T4 is 9. As you see, which one is which of these spanning trees has the least weight? This one, T4. That means T4, let's say it's T5, sorry. T5 among these, we say T5 is the minimum total weight, is the minimum spanning tree. So the minimum spanning tree is this one. We just draw this spanning tree. Okay. We will take some examples about that later on to find the spanning tree of a given graph. Okay, and I'm going to tell you the procedure of finding the minimum spanning tree, how to start to find the spanning tree. Here, we say this is this highlighted one, this colored one as the minimum spanning tree. So the minimum spanning tree here is that one, which is given. So here we just say, let me draw it here. So the minimum spanning tree is this one. from this. This is the Minion spanning tree. We just draw this one. Okay? We draw this spanning tree. We just draw the spanning tree. Yeah, this spanning tree contains all the edge, all the vertices, and it has the least weight, the minimum weight. We now have an example. Let's take a break for 10 minutes. We will try to solve this example. We have this example. It's about muddy steep problem. Here, this is the story. Once upon a time, there was a sea that had no roads. Getting around the sea was particularly difficult after rainstorms because the ground became very muddy. Cars got stuck in the mud and people got their boots dirty. The mayor of the city decided that some of the streets must be paved, but didn't want to spend more money than necessary because the city also wanted to build a swimming pool. This is the story, yeah. The mayor therefore specified two conditions. The first one is enough streets must be paved so that it's possible for everyone to travel from their house to anywhere else house only along paved roads, and the paving should cost as little as possible. The layout of the city is this. Here in this city, it's a muddy city. We want to make we want to find the minimum spanning tree here. Each of these houses represents a vertex. Okay, we have these houses. For these houses, we have vertices for each. Here, the number of stones here is the weight of each edge. The number of stones here is the weight of each edge. Here, the weight of this edge is 2, and the weight of this edge, as you see here, we have 3 stones. And here we have 1, 2, 3, 4. This is 4, and this one is 3, and this one is 4, and this one is 4, because here this bridge counts as 1. 1, 2, 3, 4. It's like that. Okay. First, let's draw the graph of the layout of this C. So the layout is this one. If you compare these two, here, this house is this vertex. This vertex represents that house, and this vertex represents that house. Okay. This one for the above one, and so on. Okay. Here we have this tree. We first should draw the layouts. These numbers, these are the weight of these edges. These numbers represents the number of stones here. For example, this 1, 2, 3, 4, 5 stones. Okay. So the weight of this edge is 5. Now we should find the minimum spanning tree. Yeah, we must take a tree from this graph. which contains all the vertices, and it is the minimum spanning tree. How do we do that? First, we select all the, we select all the edges from the least to greatest, okay? But here, we don't have to select 2 edges, which gets us a closed cycle. Here, the least ones are these. It's 2. Let's select all 2s if we have. This one. Checking. Seleta le kamtin waitawa. وريانك بجوري نابل صفتي 3 درجات للترياي مالنش نابل كلوز سايكل معي وقت نابل ساعو بوشي وري بي ام كلوز سايكل نابل هالشيء كويس يعني. Okay, and here we have this 2. We have no more 2s here. Now we start to select the edges with weight 3. Okay, here we have this 3. Do we need to select this one? No, because here we get a closed cycle, so we don't need to take that one. We take either this or that. Okay, and this one. How about this one? We don't have to take this, because here we get a closed cycle. And this one. Okay, what else? This one. And then this one. So it's 4. No, we don't do that first. We take this one. Do we need to take this? We don't need to take this, because as you see, this edge joins these 2 vertices, but we already took these 2 vertices. Okay, we have these 2 vertices already in the graph. Now we have this 4. Let's take and on. That's all. As you see, all the vertices are in this spanning tree. All the vertices are in this spanning tree, as you see here. So the spanning tree here is, I'm just going to draw the spanning tree. First, let's okay, see. As you see, that's it. That's it. This is the Minion spanning trees. We don't have to change any closed cycle. Yeah, we don't have to take any closed cycle. If you have any closed cycle, that means it's not a tree. But here we talk about spanning tree, so it must be tree. Okay, so this is the minimum spanning tree. Okay, may someone else don't take this one, take this one. It's okay. Yes, it's okay. It's okay to take that. But here, it must be in a way that we can travel from any vertex to any other vertex. Okay, don't take this one. Don't take. Can we travel to this vertex from this one? No, because here there is no any connection between these. Yeah, so we either take this or that. Okay, that's it. It's easy. So this is the spanning tree. Here we have 2 more examples about the Minion spanning tree. The Minion spanning tree is used in these 2 examples also. In the design of electronic circuitry, it's often necessary to make a set of pins electrically equivalent by wiring them together. Here, we can we can use the minimum spanning tree for the above one, and for the below one also. For example B, we can use it. We are running cable TV, cable TV to a set of houses, and says what's the least amount of cable needed to still connect all houses. Yeah, we want to connect all the houses by using the least amount of cable. In this case, we also can use the Minion spanning tree. We now have an algorithm for finding the minimum spanning tree. We say Traversal algorithm is used for finding the minimum spanning tree. How does it work? It starts with no nodes. We don't start with nodes or edges in this spanning tree. That means we don't care about the spanning tree. How do we do? We repeatedly add the cheapest edge that doesn't create a cycle. It's the same as we did in the previous example. It's the same as we applied in the previous example. What we do, we start from the least weight edges, okay? And we don't have to make closed cycles. This is the procedure. This is the procedure. We apply this procedure in the examples. It will be much easier to understand. Let's see. Here you have an example. It says a cable company wants to connect 5 villages. Here you have this. So it's here you have these 5 villages. Okay, to the network, which currently extends to the market town of Avonport. It says this is the network. I mean, this is the market. It says, what's the minimum length of cable needed? What's the minimum of cable? Here, we want to join these all villages with this point and all the edges together also. Here, we want the weight of each edge is given. It's a weighted graph. We have given this weighted graph, and we need to find the minimum spanning tree for this weighted graph. How do we do that? We start from the least weight one, this one. Then do you have any other 2? No. Then we do the 3 one. The edge with weight 3. Here we have this one. And we have no more edges with weight 3. Now we have this one. We have this one. We have these 2 4 weighted edges. Now we have no more 4. About 5? Yes, you have this one. And so we don't need to select any other one, because if we select any other one, we get a closed cycle. As you see, if we choose this one, we get a closed cycle, and this one we get a closed cycle, and this one we get a closed cycle, this one we get a closed cycle, and this one also. So you don't need to choose any other one. And here, by doing this, this is the minimum spanning tree. This is the minimum spanning tree, and the weight of this spanning tree is 3 plus 4 plus 2 plus 5 plus 4. That's the weight of this spanning tree. Let's see, how do we do that? We are going to order all the all the connectedness between 2 villages. Okay, E, let's say this is E, that's D, that's C, that's B, that's A, and that's F. This is our graph. We just denote each village by the first letter of their names. Now, ED is 2. We just order from the least weight to the greatest weight. Okay? ED has the least weight. It's 2. Then we have AB. AB has the least, the weight of 3. Then we have these two, this one and this one. You are free to write down which of these first. May someone write down this one first, and may someone else write down this one first. It's okay. Okay. Then in the ordering of them, we write down, let's say AE is 4 and CD is 4 also. Then BC is 5. And also EF is 5 also. Then we have FC. FC is 6. Its weight is 6. Or CF. And then we have AF is 7. We have 2 edges with weight 8. Okay. May someone write down this one first, or may someone else write down this one first? It's okay. Let's write down this one first and this one second. We say BF, its weight is 8, and FD, its weight is 8. Now, let's see which one should we choose and which one is not. Okay, the first one, it doesn't make a cycle. So we add this one. We add this one. Then the second one, AB. We add this one also. We add this one because it doesn't make a cycle. We take this one. Then AE. AE is this one. Does it make a cycle? No. So we take this one also. Let's add it. Then we have CD. CD is added. Why? Because it doesn't make a cycle. And then BC. BC is this one. If we choose this one, we get a cycle. So we don't take that one. It's not added. Then EF. EF. Yes, we take it. How about CF? CF. This one. If we take this one, we get a cycle. We don't take it. Then AF. AF is this one. Here we get a cycle. This is a cycle. We don't take it. BF. BF. This one makes a cycle. So you don't take it also. And FDE make a cycle. We don't take that also. So here, this is the minimum spanning tree. And the colored ones, as you see here. These are the iterations. These are the edges, and these are the weight of those edges. Now, as you see, the first one is added. It's the same as we did. The second is added. The third is added. The fourth is added, but this one is not, because this makes a cycle. And this one is added. So here, this one, this is B, this is C, this is A, this is D, and this is E, this is F. This one, this is the minimum spanning tree. So how about its weight? The weight of the spanning tree, the weight of this one is 3, this one is 4, this one is 2, this one is 5, and this one is 4. The weight of this minimum spanning tree is 3 plus 4 is 7. plus 5 is 12, plus 2 is 14, plus 4 is 18. So the total minimum wage is 18. The total minimum wage is 18. So you can write all the edges. Yeah, you can write all the edges. Okay. Here BC is written while we don't choose it. As you see here, it's written not added. For others, we have 3 more edges. We say not added, not added. And as you see here, for these 4 edges also, we say they are not added. Okay. You can write or not. Okay. You can write down or not. That's why. But you should write down the reason. Why don't you add them? You should say because these make cycles. That's why you don't add them. That's so easy. Here we have some important notes. It says the graph given should be a tree. So the graph that you get, I mean the spanning tree must be a tree. As you see, let's see if this satisfies the tree conditions or not. The number of vertices must be greater than the number of edges by 1. Look, how many vertices do you have? You have 6 vertices and you have 5 edges. It satisfies the tree condition. It's a tree. And you also have no cycles there. Here, if we have any loop, we must remove it first. We must remove all the loops. Okay, then we remove all the parallel edges. That means if we have 2 edges between 2 2 vertices, if you have vertex, if you have these 2 vertices, if we have 2 edges between these 2 vertices, we must remove one of them. Okay, we must remove one of them. Which one do we remove? We remove the one which has greater weight. Okay, we keep the one which has the least weight. The least weight. For example, if the weight of this one is 4 and this one is 2, which one do we remove? We remove the below one because its weight is 4. It's greater than the above one. We keep the least weight edge. Here we have an example. In this example, we should find the minimum spanning tree. Regarding to the above nodes, here we have these 2 nodes. We remove all the loops. That means if we have an edge from a vertex to itself, we remove it. We must remove it. And also, we remove all parallel edges. Which one do we remove? The greater weight. Here we have an example. In this example, we have given this graph. So we should find the minimum spanning tree for this graph. What should we do first? We must first remove the loops and the parallel edges. Okay, we must remove the loops and parallel edges. Here we have this loop, so we must remove this, and we have these 2 parallel edges. Which one should we remove? The one which weight is 9. Okay, we remove the above one because its weight is 9. We remove this one. If you remove it, I'm just gonna work on here. Here we remove this one. Why? Because it has greater weight. We leave or we keep the least weight edge. And here we have this loop, we remove it also. We remove it. Sorry? No, yeah, we don't care about numbers for the loop. We remove it. Okay? Because it's from the vertex to itself. It's a cycle. So we must remove all the loops. Now, what we do? We first must order the edge from the least weight to the greatest weight. Okay? What are the edges here? The edge, the least one. Here we have this edge and this one. These two has the same edge, which are the least weight, and the same weight, which are the least weight. We say BD, its weight is edge weight. Its weight is 2. How about DT? Is 2 also. Then bigger than 2, we have 3. AC and CD. In any order, it's okay. CD first or AC first, it's okay. In both. Let's say AC, it's 3. CD is 3 also. Now, for the weight 4, we have only this edge. We have only this edge, which CB. CB is 4. Its weight is 4. Then for weight 5, we have only this edge, BT. BT, its weight is 5. The weight is 5. Then we have AB, which its weight is 6. And then we have this one, AS, its weight is 7. And CS, its weight is 8. This is the ordering of the, it's the ordering of the edges from least to greatest. Now, we start from the least one. We start from the least one, we draw them. BD, we take this one. Then DT, can we do this? Yes, because it doesn't make a cycle. Then AC, we have this one. Then CD, can we do this? Yes, because it doesn't make a cycle. So this one is okay, this one is okay, this. How about CB? CB, if we choose it, we get a cycle, we get a closed cycle. So we don't take this one. Then BT, how about this one? We cannot do this because it gives us a cycle. AB, how about this one? It's also, we cannot take it because here we got this closed cycle. AS, yes, we can do it. CS, no, we cannot. We cannot do this because here we get it gives us this closed cycle. Okay, so this one is not. That's all. So now this is the minimum spanning tree. This is what we get is the minimum spanning tree. Look, it's the steps of doing it. First, we remove these two, I mean the loops and the parallel edges. We get this graph. I just removed in the above slide. Now we arrange all edges in the increasing order of weight. BT is 2, DT is 2. It's the same. I did it in as a column. Here it's given as rows. Now it says the least weight is 2, and the edge involved are BT and DT. We can choose both because it doesn't make a cycle. Then next weight is 3. We say it's AC and CD. We have these two. I already did these two. None of them make a cycle, that's why we choose them. And then for weight 4, we have only this one, and it gives a cycle. That's why we don't have to choose that one. Okay, we ignore it. We ignore this one. Why? Because it gives us a cycle. As if we choose this, and if we choose this one, it gives us a cycle, a closed cycle. That's why we don't choose it. And then we do it step by step for all the other weighted edges. Okay, and this is the spanning tree. It's the same as we did the, look, we did this one. That one is. This is S. This is the spanning tree. S, A, C, B, D, T. And you should write down the weight of each edge here. 3, 3, 2, 2. And the minimum weight here, the total minimum weight, is the sum of all these weights. 7 plus 3 plus 3 plus 2 plus 2 was 17. So it's 17. The total minimum weight is 17. That's it. And you should do it step by step, like as it's done here. I did all on its graph. Let me remove this. You should do it step by step as it's done here. Okay. First, we remove the loops and parallel edges, and we keep the minimum weight of the edge in the parallel edges. Now we arrange the edges in the increasing order of weight. Then we choose the edges. We choose the edges to get the minimum spanning tree. We start from the least weight to the greatest weight. We don't choose any of them, which gives us a cycle. And we get this one. This is the graph. And it's the end of this chapter, and it's enough for today.